Okay, good morning, everyone. Welcome to the 2020 Dev Summit. In here, we have two of us. Colin, introduce yourself.
Yes, I'm a lead PE on the Geodatabase team here in Redlands. And I'm sitting here with?
Eric Hole. I'm the dev lead on the Geodatabase team. How long have you been here, Colin?
I've been here 16 years this year.
No, I mean in this room.
Oh, in this room, not 16 years.
Okay. I've been here 22 years, so we have a little bit of experience between the two of us.
A wee bit.
Okay, so today we're going to take you through an interesting topic, effective geodatabase programming. Now, what's interesting is when we first started the Dev Summit back in 2006, this was one of the original presentations. I think it was called Turbocharging the Geodatabase or something like that, something a little more freewheeling. But it's an important topic, and there is some confusion out there. Although there's a tremendous amount of doc and all that available, the geodatabase is a sophisticated system, and to understand the APIs and how to use them most effectively is something you need to study a little bit. As with many things, there are different ways to do things, and pay attention to the best ways to do things. So one of the nice things is with the new Managed Pro SDK, things are a lot more obvious, and you have a few less choices in terms of how you get from here to there, and usually everything that's exposed is optimized, so you don't have to sweat some of the details that you used to have to do with ArcGIS as much. Anyway, well, let's get through this thing. Yeah, we're trying to talk about all kinds of things that will allow you to be a really effective geodatabase programmer. This is both either ArcObjects or Pro-Managed SDK. We'll also be giving you a little bit of editorials talking about how we conceptualize the architecture, how we view things, and a lot of, like the slide says, we're going to be really focusing on what are the best practices. What should you be doing in the most effective manner? What are the questions that people oftentimes have for us or on discussion forums and whatnot? And then talk a little bit about some of the new programming patterns that we do see with the Pro-Managed SDK. So, this presentation, we will assume that you do understand the geodatabase and you have done some programming against the geodatabase, whether you're using the ArcObjects API or the Pro-Managed SDK. We do assume that you know something about that and have some experience. The code examples will be in various languages. We tend to be a little bit agnostic about that. There's a lot of content, very little time. Save it questions for the showcase in 2021. Okay, these are intended to be used as a reference for you, okay? These are the main topics that we're going to go through. We'll talk about unique instancing inside the geodatabase. We'll go through the cursor model. We'll talk about caching data, both spatial feature data as well as schema information. Then take you through schema locks, talk about the Pro-Managed SDK, and then provide you with a discussion of the top developer mistakes and what things to avoid. Okay? So, starting things off, unique instancing of objects. Now, one of the things that we've always tried, or we implemented in the geodatabase model, was to try to ensure that when you instantiate an object, there's at most one instance of that object instantiated. Sort of like a COM singleton model. Now, when we talk about unique or single instancing, say you open up a table or a feature class or a feature data set or a workspace. When you open up these things, although you may have many references to this item through your pointers and variables and all that, behind the scenes there's only one instance. So if you edit one of these things through one interface pointer, one of the pointers, it'll be reflected on the back end, and then other pointers that are also referencing the same object will see those changes. So regardless of the API that hands it out, you'll get the same reference. So again, changes to the object affect all holders of the reference to the object. So here are some simple little examples. where you can see in the top where we're, let's see, opening up a versioned workspace, and then we ask for the default version. It goes into default 1, and in default 2, we use a different method, and we call find versions, specifying the default version name. And if we go and look at, are they equal to each other? Yes, they are. Although we use different APIs to get two different references to the version object, they are equivalent, a single instance. We're doing something similar on the bottom where we're opening up feature classes using two different sort of approaches. One where we have unqualified feature class names, and then the other we have fully qualified feature class names. Also, opening up the feature data set, we can then also go through the feature data set instead of the workspace to try and open up the same feature class. And in all cases, you get the same instance of the object. Okay? So it doesn't matter whether you're asking for the feature class through the workspace, either qualified or unqualified, or navigating to the feature data set and asking for the class by name, you will still get the same instance. Okay, now here's a special case though, something that you do need to pay attention to. And basically rows or feature objects are uniquely instanced only within an edit session. So in this example, we see up at the top, we're opening up a feature class, then right away we're asking for feature 1. And if we look at that, we see that feature 1, the object that's being referenced by F1 is not the same object that's being referenced by F2. And that's because you're not in an edit session. If instead we start multi-user editing that you see on the bottom and we ask for the same feature twice, this time they will be uniquely instanced. So it's very important for feature at the feature and row level, be within an edit session to get your unique instancing. Cursors. Cursors are an interesting topic. They're the way, of course, that you pull data out, search for data, update data, insert data into your tables and feature classes, but they do have some subtleties that you need to keep in mind. Now, what we're talking about here does not apply to the Pro-Managed SDK. The Pro-Managed SDK does not have the concept of search, update, and insert cursors. This is for more the ArcObject style developer. So we have those three types, search, update, and insert. We also have a query def cursor for when you're working with sort of defined queries where you can join tables together, who knows what. Now, I didn't want to go quite that fast. Now, what's the difference here? When you're using one of the class cursors, search, insert, or update, what's going to be interesting is any row that is returned to you will be bound to that particular class that created the cursor. Okay? Whereas the rows that are returned by a query def are not bound to the class. Okay? So let's go through some examples to make it a little bit more clear. Up on the top, we can see we're opening up a workspace, we're opening up the parcels table, then we're getting a search cursor out of it. Once we have the search cursor, we can we grab a row out of that out of the parcels table. Then we call get table, and we go to see whether or not the row table that we have from the row. This is confusing. Okay, I'm sorry. We have the row object. Then from the row object, we ask for the table. The search cursor that handed this out has bound the row to the table, so the table that's handed back by the row object will be equal to the table that we opened at the workspace level. That's why it says true. Now on the bottom we do have the query def, and remember the query def, as we said before, is not binding the row objects to the table. So in the bottom we see we're creating a query def, we set the tables to parcels, same as above. We then get a cursor out of the query def, and we ask for a row. We get the query row out of the cursor. Alternatively, then on the bottom, we say from the row, get the table. And what happens is the row does not have a table. It's not bound to a table, so an exception is thrown, and we'll get the automation exception that you see on the bottom. Again, Cursors that come from query defs are not binding the rows to tables, whereas cursors, the cursors that are class cursors, the insert, update, and search cursors do bind the row objects to a table. Okay, now search cursors. It's basically a all-purpose class-based query API. You call, table search to get the search cursor back. You can call get row, get rows. There's all kinds of different ways that you can do that. Now, what's interesting about these cursors is if you are in an edit session, we may use a cache that we maintain, the object pool, or if you do have a spatial or feature class to satisfy that query. Okay? Now, one thing that can happen is when you are using it within an edit session, you can essentially flush the cached rows when updates are done. You can have database writes occur. So let's see. If you're going to go and modify the row object, you can call store or delete on it. If you're using cursors other than a search cursor, you would be able to do insert row, update row, or delete row. Let's go through some different examples. On an update cursor, think of that as a positional update cursor. So what you're going to do is you'll call next row on it, then you can update the row. Then you can ask for the next row off the cursor object, update it if you choose to. So it's positional. You're kind of working your way through it, and you can call update row on the cursor itself to update the row that it is pointing at and that you're referencing. The APIs that you use to create it, you can go to the update method on the iTable or the update method again on a selection set. One thing that's interesting about these is they are never satisfied by any kind of a caching mechanism. Okay? Let's see. To go and update the rows, to modify the rows, you would call update row or delete row on the cursor, on the update cursor itself. And don't mix and match those things with store and delete operations on the feature. Now, something to keep in mind, if the class is supporting store events, and again, this is ArcObjects, this is not the Pro-Managed SDK that we're talking about here. If the class does support store events, and these are things for example, the features that are associated with a geometric network. What we'll do is, although you're asking for an update cursor to create it, internally we'll create a search cursor, and the update row and delete row method are essentially equivalent to row.store or row.delete. How do you know if the class that you're working with needs to support store events? If it's non-simple, okay, class is participating in a geometric network, or relationships if you've enabled relationships or enabled messaging on the relationships. Also, if you've implemented a custom feature. Very few people do that anymore. Now, with the update row, let's see, you'll get an error if it's called on a row that was didn't come from an update cursor, or if you're calling it on a row that's not the current position inside your update cursor. Remember, your update cursor is essentially a positional update cursor. Now, insert cursors. When do we use those? They're used primarily for bulk inserts, and you would call on the table, on the iTable interface, call it the insert method to grab back and insert cursor, and that will give you the best performance available for inserting large numbers of features doing bulk inserts. Now, if the class is non-simple and supports store events, then search cursor semantics will be used. Okay, we talked about that previously. Now, when do you want to have buffering? Buffering, if you're inserting a large number of things, you want to batch them up before you communicate with the underlying database instance for persisting those features. So when you call insert on the iTable to get the insert cursor, you can set use buffering to true. Then what happens is you will be responsible for periodically calling flush on the insert cursor in order to push it out to the database. A good rule of thumb is use maybe 1,000 rows at a time. The higher the number or the longer that you wait, the less network traffic you'll have. But if there is an error that occurs during that operation, that means you'll have to do more reinsertion of those features that you are inserting. Okay? And also try to ensure that when you're using insert cursors, there's no spatial cache in operation, because that will require extra processing to keep the cache synchronized with the inserts that you're being made. Okay? Now, when you are using insert row and flush, be sure you have the proper error handling. If the flush operation fails, you're going to have to reinsert all those rows that you were trying to insert since the last time you had a successful flush operation. Query def cursors. Now remember, these are the unusual ones where you're essentially specifying a user-defined query, and it will not bind the row objects to a particular class. Okay? Query def cursors will always bypass the row cache, and if you call evaluate within an edit session, it will cause all the cached rows to be flushed. And store and delete are not supported on query def cursors. Essentially, you're not updating information with query def cursors. You're just reading information out of the system. Recycling cursors. This is a little bit of a different perspective on the problem. A recycling cursor is a cursor that doesn't create a new client-side row object that it holds in memory for each row that's retrieved from the database. So when you're reading out lots of rows, you're not having to reallocate new row objects. It can be reused if you have recycling set to true. So again, internal data structures and objects will be reused. That is good for your memory footprint, and also for your object instances will be reused, things such as geometry. So with all the methods that allow you to create cursors, if the recycling is supported, there will be an argument that you set recycling equals to true to get recycling enabled. Now, what are the interfaces that support recycling cursors? Well, we can see with our class cursor, some of them. You can get rows, get features, search, update. To get our insert cursors, a search and update, as well as update rows. Everything that you would expect at the class cursor level, we try to enable that whenever possible for searching and updating. Here's a little example showing that when you call next row on a search cursor where recycling is enabled, you're going to get back the same row instance. So here, again, we're opening up the road node table, and there we're creating, having a search cursor to return all the rows. We set recycling to true. Then with this, with the search cursor, positional cursor, we're then, or actually no, I'm sorry. We ask for the first row, for a next row, then we ask for the second row, and we try to see whether or not they are equal. And yes, they are, because we set recycling equal to true, so the row objects are the same. Now, the data contained within, so it's the same piece of memory, the same structures and all that. That's why first row and second row are equal. Essentially, when you call next row to get the second row, it's overriding the piece of memory, the row object that had been populated with the first row. Okay, here's a different example. Again, search cursor where we set recycling to true. And we're looking for a field named location inside it. We get back the geometry out of the location field. Then we get the second row. We ask for it back. And again, we ask for the geometry back. So we have a first geometry reference and a second geometry reference. And these two geometry references will point to the same structure, the same piece of memory, because you are working with a recycling search cursor. Okay? Although you've called next row twice, they will reference the same piece of geometry. And actually, they will reference the piece of geometry that was returned the second time you called next row. The original time would be overwritten.
Do you know what I notice in your code example here? An excellent point is that it's not guaranteed that the feature class's shape field is named shape. So there is a property on the feature class where you can ask for the shape field name, in this case location, and when you're programming, you should always do that instead of hard coding it to shape.
That's a very good point. Yeah, we do not constrain the system to use shape as the name of your shape field or your geometry. And actually, if you look at some of our tables, some of our internal tables, we use different names for the geometry of a feature object.
Yeah, it's a good thing to keep in mind.
Yep, very good. Good point. Okay, recycling cursors. When do you want to use them? If you don't need to persist a reference to the row object. Okay, if you're not saving or persisting it, don't. You can use recycling cursors. Don't pass the row objects that you get from recycling cursors around. If you have a method that needs to return a row object, it's probably best not to use a recycling cursor, because the client may not realize that what you're handing back is the result of a recycling cursor. So when they call your method a second time, they may, the row objects would be identical, the references to them. That can cause bugs in your code. Okay, so be careful about that. Also, you never directly edit a recycled row, and if you do properly use them, you can really lower the memory footprint and resource footprint of your application. Here's a little toy example. And here we're using a, we're showing a recycling cursor, search cursor, and we're just reading all the row objects. We have recycling as an argument to it. Our test data set, let's say it has 50,000 rows with maybe 75 fields. And then we have a breakpoint there. And let's see what the memory consumption is. If you set recycling true to this run little toy example, if it is recycling, when we ran it through a symbolic debugger, Visual Studio, we saw about a 60 meg memory footprint for this collection of data. However, when we set recycling to false, we had an 185 megabyte footprint. And that is because we had all the distinct row objects. We had 50,000 row objects when recycling was false, whereas when recycling was true, we had one row object, essentially. Non-recycling cursors. That's sort of the opposite. That's a cursor when it's non-recycling that will create a new client-side row object for each row that we're returning back to you from the underlying data store. We will create new data structures and objects. We'll create new geometries. Okay, that's why it takes more memory. So for any API that will hand back cursors of which you can get either a recycling or non-recycling, you'll just set recycling to false to get the non-recycling cursors. When do you want to use them? It's kind of the opposite. If you want to have references to the current row that you need to persist, you'll use non-recycling. If you want to cache a lot of data, have long-lived references, you would use non-recycling cursors. Some geodatabase APIs do take sets of rows, collections of rows. In that case, you would want to be using non-recycling cursors to grab the row objects such that you can then pass them to other geodatabase APIs. And when you're editing, you edit non-recycling rows, non-recycled rows. Okay? When should you release? Here are some questions, some good to-dos, best practices. When should you release the reference? Essentially, as soon as possible. If you can get rid of the reference to the cursor, get rid of them right away. Okay? As soon as you're done with it, release it. If you need to use the cursor inside an edit session, okay? When should you create the cursor? Well, essentially inside the edit session. It's kind of a funny trick question, but yeah. Do not create your cursors outside of the edit operation. Create them inside the edit operation. And be sure to always release things, okay? Let's see, the next one. Should I use a search cursor to update rows? Well, that seems kind of weird, but I'm trying to update a row. Wouldn't I use an update cursor? Well, actually, yes. Use a search cursor. Using search cursors within an edit session is actually the recommended way to update rows in the system. Now, say you are editing data. What type of cursors should you be using? On the horizontal axis, we differentiate between whether you're inside or outside of an edit session. And in the vertical, we are looking at, first, are you using the desktop application, either ArcMap or Pro? Are you running an engine application, essentially a headless application just hitting ArcObjects? Or are you hitting a headless application outside of our desktop application, but working with complex data such as network features or relationship classes with messaging turned on? And in every one of these instances, except for a headless application outside of an edit session, you should use a search cursor. Okay? So, use search cursors almost all the time, unless you're doing things outside of an edit session against simple data in a headless engine application. Do we still say headless engine applications?
I still say headless engine applications.
Well, you've been here 16 years.
Well, therefore we do.
Okay, let's see. Caching data. What is the spatial cache? It's basically a client-side caching of feature values over a given extent. It was called the map cache way back in ArcMap in the 9.0 days. It's had different names over time, but it's doing the same basic thing. The nice thing is sometimes if you do have a spatial cache, it can speed up queries because cursors will try to resolve themselves whenever possible using the spatial cache in order to reduce the round trips to the database. If you're doing many spatial queries within a common extent, say you're doing a whole bunch of work in one area, sure, use your spatial cache. On the spatial cache, through the spatial cache manager, you can fill the cache, you can empty the cache. You can also tell it to cache a given extent. Okay. And here's some of the help doc that you'll see when you are working with the spatial cache manager interface. And you can find that interface on version workspaces or regular workspaces. Okay. Here's a little example. Here we have, it looks like some parcel data or something like that. Let's say you were going to do a spatial query over in the northwest corner. Okay, that's my first query. Second query is down the southwest. Well, where's the next one going? Kind of the eastern area. But I have these three spatial queries in this area that I'm working with now. And then we also have a fourth down in the southwest, down in the Florida area. Now, if we did have a spatial cache and we cached this area that's represented by the red dashed lines, we could do that by opening up the FeatureClass. And then from there, we can say, fill the cache, specifying the query envelope. And if the cache has been filled, it'll execute the queries within the cache extent. Now, similar to the spatial cache, we also have a schema cache. Schema cache, think of it as being a snapshot of the geodatabase schema. You know, all the feature classes, all the table metadata, relationship class metadata, network metadata, domains, all the rest. Now, in order to use the schema cache, you're going to want to have a static data model. You're not going to want to be adding feature classes and tables and other metadata to your system, okay? Because if you have a schema cache that's active, when you're trying to do these DDL operations, it will not be reflected in the cache. However, when you are opening up a number of data sets, it can improve the system performance because you don't have to read the geodatabase system tables more than once in order to get the metadata out that's needed when you actually open up these data set instances. Okay. And here's the interface that you can essentially control the schema cache with. And you can show that you can enable all the schema caches for all open workspaces or just a specific workspace, refresh things if things are done to the DML operations have been done. Oh, this is very touchy. Sorry about that. In any event, this is the interface that you'll be working with to control the schema cache. When do you use it? Well, we've already talked about that. How to use it? You'd want to enable it before you open up a whole bunch of tables. So if you repeatedly call open FeatureClass open table or run the open method on a name object, it'll optimize it and it'll minimize the traffic to the database. You'll be able to satisfy the operation using the schema cached information. Cache does need to be fresh. You can put in controls such that if it detects that the cache is stale, to refresh it. You are also responsible for disabling the schema cache. Okay? You must disable it before you release your workspace. If the workspace, you're caching the table information, the metadata information, the schema information in the workspace itself. How to use it? Okay, here we have the workspace factory. We get we're essentially getting workspace factory schema cache interface off of the workspace factory, and we're calling open on it to get a workspace back. Then we can, on that individual workspace, we can then enable the schema cache. Then we do our operations to open up feature classes, and you can do a whole bunch of them in there. Then once you've opened up everything that you need in your application, you can then call disable schema cache. Okay. Well, I guess this kind of said what I was talking about. Okay. Some of the gotchas, of course, we mentioned earlier, the schema cache becoming stale. If Geodatabase schema changes have occurred, they will not be visible inside your schema cache until you refresh your schema cache.
Whew. Yeah, let's talk about
you, Colin. You're more interesting.
Talk about another type of schema operation. This time it's a schema locks. So schema locks prevent clashes with other users when they are accessing the geodatabase's structure. The schema locks need to be promoted from shared to exclusive if you want to make a modification, meaning that you are the only accessor of that class. Shared locks are automatically applied every time you open an object, and as developers, it's our responsibility to promote to exclusive before we try to do our modifications. The exclusive locks, they are not automatically applied, not like taking the shared lock. So when do we want to use one? Well, like I said, it's when we want to make modifications to the class's information. This is usually information that matches directly to something that is modified via iClass schema edit. So something like adding a field or assigning the data set to another extension data set, like a topology or a geometric network. There's some cases that are slightly more surprising. For instance, adding a value to a coded value domain also requires that you take exclusive locks. So like I said, as a developer, it's our responsibility to take and demote these locks to make sure that other people can then access the class afterwards. It's also a really good idea to keep the length of the exclusive lock to a minimum. So if you have a GUI implementation that's asking the user for information, filling out maybe a field set and all of its properties, we would cache all that information and then promote to an exclusive lock, modify the class's schema, and demote immediately. It's really important that demotion happens within the normal flow of our program, as well as all error cases. Okay, so the next thing I want to talk about a little bit is core.data, and this is the Pro SDK C#.NET managed SDK for Pro add-ins. So the ArcGIS Pro isn't written using the managed SDK that we provide for extending the application. In ArcObjects, in ArcMap days, that's how we did it. We wrote the internal guts and then put them out. In this time, we took a step back and said, how can we present a more friendly and more coherent SDK to the developer? And that's the approach we took here. It is written in .NET. It's a .NET API. It is slightly more coarse-grained than the ArcObjects API, but you can do the same pieces of work. As I said, it's primarily designed as an add-in extensibility mechanism for ArcGIS Pro, and therefore lets you extend the application in a way that is not as tightly coupled as ArcObjects class extensions. So ArcGIS Pro has been growing in its level of functionality. One of the things that Core Data did was choose to be a DML only, a data manipulation language only API. This means that we can't perform schema creation or schema modification from the API. It doesn't mean that you can't do those things. In fact, you can call geoprocessing tools to do those pieces, either from the API directly or via scripted patterns within ArcGIS Pro. Okay, as I said, the SDK has been growing at each release. Each release we continue to add more and more functionality, and this will continue. Here are just a couple of the examples. In 1.1, when the first Pro SDK was released, we had basically what was the web geodatabase support level. That's file geodatabase, enterprise, simple tables, feature classes, domain subtypes, relationship classes. At 1.2, we introduced versioning and supported feature services. At 1.3, we added database access, that's query layer support, along with query definitions that Eric talked about before. 1.4, we added joins to help with generating those joins between tables. We added SQL syntax helper class, and we introduced feature services as a geodatabase. 2.0 was our first chance to make breaking changes with a major release, and we introduced the abstract class of Datastore. We introduced raster support at that release. We introduced the ability to work with blobs, and we removed, in our great wisdom, Datastore.getPath because it didn't work correctly with enterprises. At 2.1, we introduced annotation and realized our mistake of 2.0 and reintroduced Datastore.getPath. And this, in its reintroduction, greatly enhances the ability to use it when you want to call a geoprocessing tool. So you can now, for all of our workspaces, get the path and build the path that you have to pass to the string. The path that you have to pass to the string argument of the geoprocessing tool. We also introduced the idea of getting the ID for the unique class instance, as well as extended the versioning support.
And some of the subsequent releases to that, didn't we push on the utility network APIs?
Yes, the utility after 2.1, the utility network API was exposed and has greatly expanded what you can do with the utility network.
Any DDL in there?
No DDL yet, but I would say that this is definitely a growing SDK. DDL has been raised as an interesting capability for users and is certainly being looked at, along with a pattern for inserting features at a rapid pace.
Yes. And that's a key point that Colin is raising and is demonstrating here, is that the Pro Managed SDK is a growing and living beast, and it is being enhanced with each and every release. So it's becoming quite rich these days.
It is. So let's take a little look at the architecture. At the bottom of the stack, we do have ArcObjects behind ArcGIS Pro, and the same for our SDK. It has a small C++ wrapper layer that exposes it to .NET, and that that C#.NET layer is what the Pro SDK, the managed SDK, is exposed as. And then at the top of that stack, we have the clients that are writing add-ins with that managed SDK. This is the same or a similar architecture to how Pro itself is built. However, we don't use the same managed APIs. We expose those managed APIs in a more consumable format for our add-in authoring.
We're hiding our dirty laundry, you're saying?
It's possible that there is dirty laundry being hidden, yes. Okay, let's take a look at exactly what we have exposed in the SDK. So the first thing that we have is this concept of data stores, and you can think of these as how you open your workspaces, your Geodatabase or a database. There are other types of data stores as well. There's file systems, there are SQLite connections, file geodatabase, and services connections. So one thing you'll notice is that in the Pro SDK, we have this constructor pattern where we provide you the different properties that you must set instead of making you guess at which strings you can set. So hopefully this pattern makes connecting to a data store a little bit easier. In the Pro SDK, we took a slightly different take on things. We have data sets like we did. We also have definitions, and the definitions hold the information about those classes that is interesting. So for instance, here is a table inheriting from data set. Table has all the methods that you would expect, and get count, get ID, search, those sorts of things. From the table definition, you will see all of the interesting pieces of metadata, right? Getting the fields, getting the model name, getting the subtype field. Does it have global IDs? Does it have an object ID, etc.? So these table definitions are very lightweight pieces of information about the tables. They don't incur the cost of opening the table, but you can get information about the table via those patterns. So then, being a spatial company, we have feature classes. These are basically tables that extend the feature, tables that extend the table with a spatial column, and you can see in the feature class definition that you can get the shape field. And this way you don't have to guess at what that might be named. So we don't make a mistake and try to open a shape field that doesn't exist when it's really called location, for instance. So both table definitions and feature class definitions, as I said, were these lightweight objects, and they give you more information about those things. From a table or a feature class, you can get a row or a feature. And this API is very row-centric. Most of the work happens from the row itself. You can see that we can, on here, we can update the attachments directly from the row instead of going through an I attachment manager. You can get the object IDs and the global IDs and the fields directly from the row. You can also get a reference back to the table if the row returned does support it. You can get the original value for a feature too when you're in an edit session. Yes, very handy. So how do we filter these tables when we're trying to get rows from them? Well, that's with a query filter, returning a RowCursor or a selection. So here we have a table, and we can ask for those rows in a RowCursor, and we can filter them with a query filter, or if we want to do a spatial filter and have a spatial relationship, then we assign those properties. From the table, you can also ask for a selection, and in that case, you'll get a selection back, for which you can get the count of the number of features or combine that with a previous selection.
So that's interesting. So we don't have search, update, and insert cursors?
No. In the Pro SDK, we do not have the 3 types of insert cursors that Eric spent so much time on. We have taken a pattern where we expose all of the work done at the RowCursor level. So we did introduce the concept of query definitions. They are very powerful. They give you the ability to join tables at a relatively low level. if those tables happen to exist in the same data store. You can persist those joined tables as a query table description and use those in a layer or a geoprocessing tool. So at 1.3, I mentioned that we added database access to the Pro SDK. And here you can see you can connect to a database, any of the RDBMSs that we support that do not have our internal geodatabase metadata tables, and open the tables as spatial objects using a query description. At 1.4, we introduced the ability to create joins. So joins can be used in a similar fashion to query defs, except for they happen to support the ability to do joins across data stores. So between an enterprise geodatabase and a file geodatabase, for instance. Now, if they are within the same data store, we will work very hard to push that query down to the database to make it as fast as possible for you. 2.1, along came versioning and the ability to create, delete, or update the access patterns for versions. You can also access historic versions via the version manager on a class. You can see if versioning is supported on the workspace by asking the geodatabase, is versioning supported? So here are some links to the Pro SDK's conceptual help, along with the community examples. This is where we talk about the different patterns. I would encourage you to look at the editing SDK as well. If you are within an add-in, you should be editing with the Editings SDK. Okay. Let's take a little second to talk about some top developer mistakes we've seen over the years. Okay, I think the first one is quite common and has been quite common, and that's why we have an entire section devoted to it. It's the misuse of recycling cursors. So they do have a large amount of performance benefits if used correctly, but they can be a little bit confusing, right? Comparing the first geometry to the second geometry returned. So let's just take a look at that again. Here we have a feature class where we call search. We get a feature cursor, and we get the first row and the second row from it, and store those in feature 1 and feature 2. Oops. And then we ask if those things are equal. And it may be surprising to find out that they are equal, even though we have fetched 2 rows. So just keep that in mind. Here's my personal pet peeve. It is seeing code that is explicitly looking up a field name inside of a tight loop. Okay, don't do this. What you should be doing is asking for the index of the field by its name outside of the loop, and then accessing the field value by that index. Okay. I didn't like this pattern so much that in the Pro SDK, we cache that value for you. So it is okay to do what I've written below in the Pro SDK, but in ArcObjects, please, this does have a cost, and it can improve your performance. So in C#, I often get this question in this session, and since I can't get that question this year, I've added this slide. Yes, I will answer this question. How do I release objects? There is a concept in C# called Marshal, and in the Marshal you can release the COM object. And in this little example here, we do that until all of the references are gone. In the Pro SDK, there is a dispose concept. Many of almost all the objects that need to be disposed do support dispose. So what things do you want to do these on? Data sets like tables, feature classes, workspace, cursors, rows from those cursors, and potentially geometries from those rows. That's just a small example. So when you are creating these cursors and you are editing, make sure that you correctly scope the lifetime of the cursor to your edit operations. If you attempt to use the cursor across 2 edit operations, you will return an error. We started to block this at 10.0 to protect users. So this is basically saying that if you're going to start a new edit operation, start a new cursor. Okay, so there are some methods in the ArcObjects SDK that actually create data or modify data. Those are things like create table or add field, and these should not be done inside of an edit session. It's one of the most highly requested ideas on the ideas site, and it is not a good idea. Why is it not a good idea? Well, on some of the DBMSs that we support as backing stores to the Geodatabase, that DDL causes a commit, and those things can no longer be undone or aborted. And that may be very surprising to your application. So try not to call these things inside of an edit session. If you need to create a table for your edit session, do that prior. Okay, following along with that, calling store inside of a store triggered event. This is a no-no. Do not do that. Why would you not want to do that? Seems like I just modified a row inside of my store event. Seems like it could be a good thing. Here, I'll show you an example of what that might look like, along with another case. I've modified the shape in this example, and I call store. Well, if I called store, we'll fire another event, and you will get another store event, and we will go into an infinite recursive loop on that. Here's another example where you shouldn't modify the shape. That's on a create feature event. Why is this important? Well, there are parts of our system, mainly network features, that rely heavily on the spatial piece of that shape being created for additional work, basically the network topology that needs to be updated. What is it connected to? And if you modify that in the on creation events, then our system gets out of sync and bad things will happen. So remember not to change the geometry on create feature events. This one is more of a pattern that we should look out for. ArcObjects gave you lots of ways to do things, and not all of them were always the best way. I am also slightly lazy, and I don't want to create a set of features, so I often write get feature over and over again. But ideally, in places where we know we're going to be getting a list of things, we should ask for the plural method, the get features method. Okay, this is just something to look out for. It's often super easy when you're prototyping code to just call get feature, but if you're going to do more than one feature, try to look for the plural of that interface. Here's one from internally. A group thought that calling open on the name object would cache the reference to the returned data set. It does not. If you want to keep a data set open, you must keep the full table or feature class open. Having the name object does not cache the data set. Careless reuse of variables. Eric's laughing, but this is a case that we often get via email as well, saying like something, the Geodatabase is broken today here in development, and we say, oh really, is it broken? Can you send me the case? And they send us a piece of code that looks something like this, where while they're creating a field set, they don't correctly reinstantiate the field edit, right? So each time in between we creating a field, here we're creating an object ID and giving it some properties, and then we add field to a collection in memory, and then we create a name field and we change its type of string and we add that to in memory. But at no point did we call, say, new field on the field that we're modifying, meaning we're effectively on the same reused variable, modifying the in-memory representation. What this would look like is a feature class that got created with 2 name fields. The Geodatabase is not broken there, and can be easily solved by simply saying, new field on each of these fields that we're going to add to the in-memory collection. So there are different APIs that we can use to modify our Geodatabase data sets. Some of those things can be modified within memory, and some of them we need to use the proper API to make sure that they are persisted. One example of this is that you could change a field set for a feature class in memory using that add field that I just showed you previously, but those are not actually persistent until you call the proper API. For instance, iClass add field or iFields edit add field. And this will make sure that those things that you modified in memory get persisted in the Geodatabase and are seen the next time you open the class. Okay, so one of the questions I often get asked is, when I'm creating a relationship class, should I have messaging? And the answer is no, unless you're going to explicitly write code to take advantage of that. Some relationship classes, Composite, for example, come with forward messaging, and that is the only case in which ArcGIS, ArcMap, or Pro will take advantage of the messaging without extending the code. It does have a cost. The messaging between relationship classes does have a cost when you're doing editing. If you do want to have messaging and have a valid use case for it, like you're going to extend it to listen to those events and do some work on those events, you can mitigate the performance hit by making sure that the destination classes are open prior to making the edits to the origin class. This saves us from repeatedly opening and closing those destination classes. So that was a list of the top developer mistakes. I hope you have not made any of those, but if you do, you can go back, check those code, talk to your colleagues, and then fix some of those cases. I think that is it for this year, Eric.
Let's see, does the crowd have any questions? Yes, sir. Colin. Okay, we'll repeat it for the crowd.
Okay.
The gentleman in front would like to know where you bought those shoes.
Oh, I had to order these shoes online.
Okay.
Yeah, I can send you a link. Just come up and talk to us afterwards.
Okay. Swing by the island. We'll answer shoe questions.
We may all be living on an island, yes.
Okay. Anyway, thank you very much, everyone. Hopefully this will be useful to you. To recap, when you are doing ArcObjects-based programming, there's some subtlety in there. Be sure to understand the cursor model, recycling cursors, update, insert, search cursors, all the rest. That's very important. It remains a very important topic. But the other thing is, and I hope you saw a little bit of this during Colin's part of the talk, where the Pro Managed SDK is actually really quite nice for authoring add-ins, custom add-ins, and all the rest. It was purposefully designed to make developing software using the Geodatabase as simple as possible. And it's not just the Geodatabase, it's all across the Pro Managed SDK. So rather than give you 25 ways of doing something, some of which are good, some of which are less efficient, we're going to give you the best method and try and make it as simple as possible. So that's a very good thing, and I hope you all enjoy using the Pro Managed SDK. And it is growing with time, and just expect it to get richer and richer. Also, avoid those mistakes that Colin pointed out at the end. Some of those really do apply whether you're using the Pro Managed SDK or ArcObjects-based development and all that. So anyway, thank you for tuning in, and we'll see you next year at the Developer Summit, hopefully.
Thank you.